All right, so picking up where we left off last time, we were looking at logical connectives. These are logical operators that bring together two Boolean variables or expressions or whatever with either a logical AND or a logical OR. Remember that the logical AND, you use this syntax, this ampersand, ampersand. Two of them. It has to be two of them. And it's true if and only if both, let's say, for example, they are a freshman and they are a student. Only if both of those things are true does this entire thing evaluate to true. It's false if the first one is false, the second one is false, or they're both false. So it's a logical AND that has to be both, not any other combination thereof. We also have a logical OR operator with the vertical pipes here. And that one has a little bit different logical expression in that it's true if at least one of its operands is true. So for example, if is student is true, or is freshman is true, or they're both true, then it's true. It is only false when they're both false. Just like plus, minus, subtraction, or multiplication, stuff like that, you can combine them in various ways. You also have PEMDAS rules with respect to logical operators. Let's go over here to an example, and let's go ahead and predict here what the results of this program are going to be. What I've done is I've done for the first one here, I've got A or B and C. Now I've set them to true, false, and false. So what do you think that the result of this is going to be? If you start reading it left to right, you'll probably get the correct answer, but for the wrong reasons, right? And the reason is that this thing is not equivalent to this thing down here. So let's understand the order of precedence. Just like multiplication and addition, multiplication is a higher order of precedence. Multiplication happens first, PEMDAS. Multiplication, addition, subtraction. So what ends up happening is this gets evaluated first. B and C. What is the resulting value of that? Remember, it's false and false, so this is going to be false. Now you look at the disjunction, the logical OR operator here. True or false. That's going to be true. And so which one of these things will get printed out? Probably this one. Right? That's going to be the one that gets that executes. Now let's come down here and look at almost the same expression, but what I've done is I've changed the order of precedence. Remember PEMDAS, the P stands for parentheses. You can place any operation that you want higher by surrounding it with parentheses like this. So in this case, A or B is going to get evaluated first. And the results of that are going to be true or false, and therefore this entire thing is true. Now the logical conjunction, the AND operator, gets evaluated, and it'll be true and false. So the result is false. So which one of these things gets executed? The false. This one. Let's go ahead and see it in action. GCC demo.c, and let's run it a.out. And we see, I guess I didn't put any end-line characters in this, but let me go ahead and do that now to make it look nice and pretty. But otherwise, we did see that true was printed and then false was printed, just as we predicted by applying those rules. All right. Let's run that again to show it nice and well formatted. There we go. All right. By the way, on your hacks and on your labs, formatting doesn't have to be exact, right? If we put, a bunch of equal signs to separate something. If you want to use hyphens instead, that's fine. If we put 10 of them and you put 12 of them, that's not going to matter. What's going to matter is that the grader is going to be looking for the key words and for the key values in your output. That's what's going to matter. Okay. So to review on these precedence operators, in general, the order is, well, actually one that we didn't look at, but the negation operator is always executed first. Then the logical AND, then the logical OR. And there are other logical operators that we're not going to get into. This is the core that we're only going to look at for this course for now. All right. So those are the precedence operators. You can always change this by adding parentheses, right, to increase, just like PEMDAS P, right? All right, I'll go ahead and put that in the notes so that you have that example at least. All right. And then there's another item that you should be aware of called short circuiting. So there are some electrical engineers in here, I believe. What is short circuiting? If you've got a circuit here, and you run like from a battery to a light, let's say, right? What can you do to that? So then it's a full circuit, so the light is lighting up. Positive charge and then negative charge back to the battery, right? Okay. So what happens if you short circuit that? You take another wire from this part of the circuit down to this part of the circuit so that electricity is not flowing to the light anymore. It's going over that short circuit back to the battery. And basically it's shut that off. Why? Because electricity, power, energy, it always tries to find the least path of resistance. There's something very similar with respect to these operators. For example, let's see where I need to find short. There we go. So consider the following expression, all right? A and B. Suppose that A is false, right? Does it matter what B is? No, why? Because it's only true if both of these are true, right? So if you are a computer and you're looking at this and, oh, A is false, and then I've got a logical AND, do I even need to bother looking at B and evaluating it if it's a variable, if it's an expression, or whatever, right? No, because regardless of the value of B, regardless of the value of B, the expression will be false because it's a logical AND. Consequently, a computer computer will completely ignore B. It won't be executed or evaluated at all. Right? And this is called short circuiting. Ignore. Now, why is this? Well, think about 50 years ago when computers were extremely slow, way slower than they are today. If you are a computer and you're executing commands, okay, well, A is false. I need to save on time because I'm a really slow computer where perhaps executing B is going to take me a second or two, right? And they did measure CPU cycles in, fractions of a second rather than millionths of a second like today. Megahertz, gigahertz, right? Those kinds of speeds, billionths of a second. And so if evaluating this is really slow, you don't do it because you need to save on time. You're already a really slow computer 50 years ago. If you can save some time by not doing something, you don't do it. And so consequently, this is called short circuiting. It won't be evaluated at all. Now let's look at another example. Consider the following. If I go with A or B. Now, just like the other one, suppose that A is true. Does it matter what B is? Nope. Why? No, because the expression will be true regardless of the value of B. Consequently, again, just as before, B is not evaluated at all. It's saving CPU cycles, and a long time ago, this actually mattered, right? Was both of them more efficient to skip operations if they are not necessary. And now you might be asking yourself, well, 50 years later, computers are way faster. It's not a huge savings. Back 50 years ago, it was a savings of a second, say. But now, today, 2024, it's only a savings of a billionth of a second. You still do it because it's still efficient and also because it's become an idiom. This has become a programming idiom. So remember that I've been trying to express the idea that writing a program is very much like writing English or writing in any language. You have punctuation, you have correct spelling, you have sentences, you have paragraphs, blocks of code, right? Languages also have idioms. So what's an example of an idiom? If you don't know that, that's fine. It's a colloquial metaphor. It's a saying. For example, if I said it's pretty hot day. But if I said that it was raining cats and dogs, all native English speakers would understand that immediately, right? If you've ever heard that expression. It means that it's raining hard, right? That's an idiom. It's something that doesn't necessarily have a literal translation, right? If I were to translate that into another language, they'd be like, what the hell are you talking about? Cats and dogs don't come out of the air, right? But if you transliterated it into another language, they would have their own idioms, right? Programming has its own idioms, right? This is unexpected behavior, or pattern, or pattern to any programming language. So even programming languages that have been created, say, in the last year or so, they're going to have short-circuiting because people have come to expect this behavior, expect and rely on it because it's an idiom. Why do we do it anymore? Why do we say some weird thing like raining cats and dogs? It's because it's become part of our language, and it's become part of the programming language and any future programming language. Even though you don't necessarily have that much savings nowadays, every programming language has something like this called short-circuiting. Okay? All right. So let's look at some pitfalls here. In other words, common mistakes. And I'm going to start by asking you what would happen if I did the following code over here. Let's just go ahead and get rid of all this and start anew here. And let's go ahead and create a variable a is equal to 5. All right? And let's go ahead and print out printf hello. All right? Is it going to print hello? What's my intention here? My intention is to see if a, which is 5, lies between 0 and 10 inclusive on both ends. That is the case because it's 5. So I would expect this to print out hello. Oops. A dot out. There we go. Hello. Right? Perfectly fine. But what happens when I go with something outside of that range, 15? If my intention is to have a between 0 and 10, should this print out hello now? It shouldn't, but what ends up happening? It does. Why? Let's understand what's going on here. It's going to be read left to right. Is 0 less than or equal to a? A being 15? Yeah. So this evaluates to true. Well, what is true in C? Generally, anything that is non-zero. 1, say. Now, is 1 less than or equal to 10? Yep. So regardless of the truth value of A, this is always going to execute. Right? So it's bad code. Right? Let me go ahead and put this up here. There we go. And go into code mode over here. So consider the following. If I go into code mode and have that there, what happens is it evaluates left to right, right? That the 0 or is less than or equal to A evaluates to true, which is 1. I'll offset that in code. And so 1 is less than or equal to 10 evaluates to true, right? Giving incorrect, unintended answers, right? So this is not code that you would write. What is the solution? The solution is to break this up into 2 statements. You can't have a statement like this. Right? I mean, you can, but it's obviously going to give you the wrong results. I need to separate this into 2 statements. Is A greater than or equal to 0, or 0 is less than or equal to A, and is A less than or equal to 10? When I split that up using a conjunction, a logical AND, now it will give me the results that I'm looking for. Right? It doesn't print anything. Else print nada. There we go. And now it'll print nada, nothing. Right? Let's go ahead and check out the other values there that we were playing around with. 5, it should print out hello, and it does. If I were to go with something that is negative on the other side of that interval or whatever, then it's also going to work, and it's going to print out nada. So the solution is to break this up into 2 parts. Right? So the solution, break it up into 2 conditions and combine them with a logical and. Remember that that's going to be ampersand, ampersand. So there's the corrected solution. I'll just go ahead and get rid of the else there. Right? Here's another common pitfall. Consider the following code, and I'll bring it over to our editor here in a second. Let's just examine it. And does anybody see immediately what the problem is? Yeah.
Instead of checking for a equals 10, it's assigned.
Yeah, there's only one equal sign there, right? So let's see what happens over here in C. I'll just go ahead and reset A to 10, and I'll get rid of this condition here. There we go. Oh, I guess that was 5. Here. There, I'll set it equal to 5 then. So clearly it's not equal to 10. If I go and try to check to see if it's 10, predict what's going to happen here. It's not going to give me the answer that I'm looking for, so clearly it's going to print hello, right? Now let's understand what's going on here. At line 13 and on to 14, the value of A is 5. What happens on line 15 is that the value of A has now been changed to 10. So let's go ahead and put in 10 here. All right. Now, tell me about 10. Is that true or false? True. And so therefore, it executes the print hello statement right here. Right? All right, so what is the fix? Well, make sure that you've got 2 equal signs there. And that will be the fix. Right? So again, what happens is that this is the assignment operator. This is incorrectly using the assignment operator, which is a single equal sign, and not the equality tester or equality operator. Right? Equals equals. Right? What happens is that the variable A, is reassigned a value that is also used as the truth value, right? Which is 10 is true. And so it gives you the incorrect results. The corrected code, as we did in the editor there, is going to be to use a proper equals equals sign. Right? One more, and then I'm going to talk to you about how you can avoid these kind of things by using a proper tool. So consider the following code here. Do you see what the problem is? Immediately? It looks wrong, right? Yeah, go ahead.
Oh, the semicolon.
Yeah, there's this weird semicolon here that I was never typing before. Let's bring this over to our example over here. Right. Indent so that it looks nice and pretty. Right. Now let's understand this. If I never wrote any square brackets, you can write code like this. I highly recommend that you don't write code like this because you get yourself into problems like we just demonstrated with this pitfall. But it is correct code. If A is equal to 10, then, and there are no curly brackets, what happens is that this statement binds itself to the next statement that it sees. Right? This code is equivalent to this code right here. But it's also way clearer right here because it's binding it to that one line. But now let me go ahead and add in that extraneous semicolon there. That's equivalent to this code right here. If A is equal to 10, do the next logical statement, the next executable statement. What is the next executable statement? Empty, nothing. Right? You can have lines of nothing. Now, if you were to write this in English, you can't really have sentences of nothing. No, an empty sentence and then a period, that doesn't make much sense. But with code, yeah, you can have an executable statement that is empty. It doesn't do anything. The compiler will probably optimize that away, but let's look at what happens when you bind that to an if statement. If A is 10, do nothing. Then move on with the rest of your program and print A is 10, even though it's not. So let's go ahead and see that A is 10 is output, even though it's not equal to 10. And that's because I've got this extraneous semicolon there. That's the corrected code. All right, so again, the issue here is that you have an extraneous semicolon. You have an extra semicolon. That should not be there. Right? The if statement ends up binding to an empty executable statement, and nothing happens, right? Then the actual code block, actual intended code block, is executed regardless of A. Right? So we don't want that. So what's the solution here? The solution is to always write 100% correct code, right? Well, that's not always going to happen. You can use a tool, though, called a linter, right? Code might be syntactically correct, but still have errors, like we've just seen these 3 different errors that are common when you're just starting out. But when you're experienced enough, you'll look at the code and you'll immediately know there's something wrong there. What the heck is that thing doing right there, right? But a linter can do that automatically for you, even in the beginning. It could compile. It may still have warnings or errors, and you'll never know about them until it's too late and you're actually running your program and getting the wrong results. So what a linter is a static analysis tool. Well, first of all, what's lint? If I were to talking about the real world, what is lint on your clothes? It's little pieces of fabric that even though you've washed your clothes, you've dried your clothes, and you're wearing your clothes, you still have little pieces of lint on there. It's not dirty, right? It's not necessarily bad if you don't care about it, right? But if you do care about it and you want to clean it up, what do? Yeah, lint roller, right? You're wearing your suit and you don't want the lint on a suit. So you take this little, thing that is kind of sticky, and then you roll it over and it picks up all the lint for you, right? A linter does something very, very similar with code, right? Lints are pieces of code that may look suspicious and may lead to errors, but that are not necessarily syntactical errors. A linter is a static analysis tool that you can use to look for such potential errors and issue warnings about them. There's probably something wrong here that you need to take a second look at here, right? Maybe you meant to do it, maybe you didn't mean to do it, but here's me warning the compiler warning you about it, right? What does static analysis mean? It simply means that the program, the linter analyzes your source code before the code compilation. Okay. Now, what I want to do is I want to restore all of these bad statements right here. So I'll go ahead and have in fact, let me go ahead and create another variable here, x, and restore that mistake. Let's go ahead and restore this mistake right here, and let's also restore this mistake right here. If a is equal to 10, then print a is equal to 10. There we go. So there are all the 3 different kinds of mistakes, and I've actually added another mistake here, right? It's a code smell, right? It potentially stinks to have a variable that you're not using, right? Here, I'm not using x. Maybe I meant for it to be used, but I didn't actually use it. Maybe I didn't mean for it to be used, and it's just cruft, it's just clutter that's still sitting in my code. What I want to do is direct GCC to tell me about all of those mistakes. GCC wall demo, or the wall flag there, demo.c, there we go. This is a flag that indicates to GCC all those warnings that you know about, tell me about them all right? That we call it the wall flag, though. And it is uppercase W, lowercase ALL. There. What compiled before with no errors at all, and it's still no errors, but I have plenty of warnings here, right? For example, that doesn't look like an equality tester to me, is what the linter is saying here. This is an assignment operator. Are you aware that what you're doing there? Right? The if clause does not guard, meaning that you've got an empty statement right after this. Right? It's not going to be all that helpful with the messages, but it's not written towards beginners. It's written towards seasoned pros. The if statement is misleadingly indented, right? And then finally, warning: unused variable x. Right? It should actually be warning about the other one. Oh, that's because I didn't. There, that's the bad one. Right, there we go. And do that again. And now it will warn about that right there. Warning: comparisons like x is less than or equal to y is less than or equal to z, right? Do not have their mathematical meaning, right? This is not math. This is coding. Coding is a little bit different than math. Just like you can't use the single equal sign like you can in algebra, you can't use mathematical notation like this in code. So it's going to warn you about that. Are you sure that's what you meant? Go back and fix those things, and you'll get a clean bill of health. Right? All of the scripts in CodePost run with the WAll flag. Right? It will actually warn you if you hand in code that has these code smells. You need to go back and you need to fix it because that is part of your grade going forward. It's part of design points. If you have warnings still there, first of all, that probably means that there's a bug in your program that you need to fix anyway. But if you still have a warning and it works perfectly fine and everything else, it's still something you have to go back and fix. For example, why did you have this variable when you never actually used it? Get rid of it. Right? So keep that in mind. Linters. Again, when you run GCC, all you need is the wall flag. When you run GCC, always use the wall flag. It stands for warnings. Warnings. All of them. All right, tell me about all of those warnings is what it's asking for. All right. And there and there. All right. Questions so far on conditionals? No? All right. Then let's go ahead and do an exercise. This is the same exercise as this morning, but it's okay. I always do this exercise because, again, we're around football time here. So how noisy was it in the stadium? Somebody reported in the morning section that it was 95 decibels. Their watch told them it was 95 decibels.
I had one that had
100 decibels. All right. Well, that game was loud, right? Decibels are a measure of noise, right? In other words, the presence of compression waves in an atmosphere, right? And we call those decibels. There is no such thing as a negative decibel, right? There is no such thing as decibels out in space because it's it's air compressions. It can be quiet, 0 to 60, and I think it's on a logarithmic scale as well. Or it can be conversational. Like if you're just talking to somebody, 61 to 70 is conversational. It can get loud though. 71 to up to 110 is characterized as loud, not yet dangerous though. 111 to 194 is dangerous because you can start to have hearing loss. This is why you don't turn your stereo up too loudly, right? Beyond that, it can actually get deadly because you do measure decibels in explosions. Those are wave compressions in atmosphere, right? And if you're caught in an explosion, it can be deadly with a high enough decibel level, right? What we're going to do is we're going to write a program that reads in a decibel level from the user and gives the user a description of that decibel level based on these criteria. Okay? All right, so let's go ahead and copy demo. Oops. Let's go ahead and copy my demo here because I don't want to start from scratch to decibel.c. There we go. And let's go ahead and remember you sometimes have to refresh this if it doesn't show up. Give myself some more real estate here. All right, what's the first thing I should do in my program? Author header. Right? Name, or if you're with a partner, both of your names. Maybe a date. It's the 9th. Yep. And then the purpose of the program. What is the purpose of the program? Reads in a decibel level from the user and gives an English characterization of it. You don't have to get fancy. You don't have to write 50 different paragraphs. Just give us something that describes what the program does. In fact, the fewer words that you use, the better. Right? We're not trying to fill out a 5-paragraph essay here. Let's go ahead and get rid of all of this code. Start from scratch. So my first question is, how do we want to do this? Do we want to read this in interactively from the user? Prompt them, please enter a decibel level, right? And then read it in using scanf. Or do we want to use command line arguments? I will say that for your hack due today, it requires that you do it interactively. So do we want to do it that way? Or, okay. All right, printf, please enter a decibel level. All right. And now I need scanf. And I'm going to be reading in a variable, but what's the placeholder for that variable? Well, now I need to decide what the variable is. All right, so should it be an integer or should it be a double? Let's come back over here. Well, from the specifications, what happens with 70.5? Decibels can be fractional values, right? What is 70.5 conversational or loud? Or loudly conversational? or something like that. This kind of tells me that we probably want to do integers. But that raises a larger issue, right? This is something called requirements elicitation. Should we allow fractional values? And if we allow fractional values, where does 70.5 fall on that? Presumably, somebody is paying you to write this program, right? If you're out in the real world. That person is called a stakeholder. You would go back to the stakeholder and you would ask them those clarifying questions. You would elicit requirements from them. Right? Are we going to have to support fractional decibel levels? Yes or no? No? Okay, we'll go with integers. Yes? Okay, now we need to go with decibels. Follow-up question, what happens with 70.5? Oh, that should fall under conversational, right? Then you get those kind of requirements by eliciting a response from them, right? All right, but we're not going to do that. We're going to keep it simple. Let's go with an integer instead. Should I call my variable x? No. X? What's X? What does it stand for? Nothing now. What should it stand for? Decibel. So a decibel, call it decibel or decibels, right? Whatever. Pluralize it or not? Decibels. Okay. Right. In that case, my scanf is going to have what placeholder to read in an integer? %d. Decibels. Now, for now, let me just go ahead and leave that. If you know what the problem is, hold on. Printf. Percent d decibels is ... and the line, and I'm going to print out decibels. There we go. Let's just go ahead and try to test this as we go along. This is called ad hoc testing. Did I get everything right up till now? Let's test it out. GCC decibel. Come on. Decibel. There we go. All right. Ooh, I've got a warning already. It's just a warning though, so let's go ahead and move on. A dot out, and our decibel level. I don't know, 42. Segmentation fault, what happened? Well, I probably should not have ignored my warnings. In fact, I should have been running this with the wall flag. wall, to see if there's anything else. No, it's just this one thing, right? Actually, now it's two warnings. The second warning is basically related to the first warning here. %d expects of type int star, but the argument is of type int. For now, that's going to be magic, remember? But what should that be a signal that I forgot on my scanf? Ampersand. Right? Just for now, it's magic, right? You have to have the ampersand there. When I fix that problem and I still keep on all the warnings go away, and I can test it, and 42 decibels is, now I can start worrying about this stuff over here. If it's 0 to 60, it's quiet. Right? So let's check if it's 0 to 60. If 0 is less than or equal to decibels, less than or equal to 60, then printf quiet. And I'll get rid of that, is quiet. All right. Let's test it. What's wrong? If I just compile with no regard to anything, I don't get warned about this. But if I were to compile this with the wall flag, it doesn't matter if you put it before or after the source file name there, right? What's it going to warn me about? Yep, that these do not have their mathematical meaning. And the solution, as you just said, is to use the and. There we go. If it's between 0 and 60, then it's quiet. Let's go ahead and, come on, go away. Compile it again and run it, and let's give it 42. 42 decibels is quiet, according to this over here. Let's continue. I'm going to cut and paste this. If it's between, say, 60 and, what was it? I guess 61 and 70. 61 and 70. Then it's conversational. Right? Now, first of all, I'm getting myself into problems here because I'm already copy-pastaing. I shouldn't have done that. But should this be two different if statements? No, I don't like it like that. Right? This should be mutually exclusive. It's either quiet or it's conversational. It's not both or some combination of those two or any of the others that we're about to do. This should not be an if statement. This should be an else if statement, right? Else if it lies between 61 and 70, then this happens. Copy pasta again, and I get myself into even more trouble here. 71 to 110 is loud. 71 to 110 is loud, right? Else, and then copy pasta again, right? There we go. And 111 to 195, yeah, is dangerous, right? So yeah, what's wrong with my copy pasting? Yeah, I changed that, but I forgot to. Oh, I did that too. All right, there we go. But I also forgot to change this. Right? Again, it's especially if you're a touch typist, that's going to cost you too much time to just write it out anew. Right? Sometimes copy pasta saves you some time, but more often than not, you're just going to make mistakes like this. Conversational, it should be loud. There we go. All right, let's go ahead and try it out. So 42 is quiet. All right. Give me another value here according to this. Say 65 should be conversational. 65, okay, conversational. Let's go ahead and 120. That's dangerous. Okay. What happens if I go with just say something right on the border there? 60. Should be quiet, right? Okay, that's correct. Right? But that's because I did it with an else if statement. If I had not done that with an else if statement, I might have gotten bad results. Let's clean this code up a little bit before we move on. Right? All right, I'm at line 22 here. If it's not between 0 and 60, ... say it's 75, and actually no, say it's 65, then I'm already at this point in the program. Do I need to check that it's greater than or equal to 61? I wouldn't be here if it were less than 60. If it were less than 60, then I would do this and I would then jump to the end of the program because each one of these things is mutually exclusive. This is an unnecessary check right here. Right? I don't need to check its lower bound. I just need to check its upper bound. Right? Likewise, this one and this one. There we go. And again, if it's 120, then this will be false, this will be false, this will be false, and then I only need to check that it's less than 195 because I know that it's already greater than 110. Okay? Let's go ahead and test that again. 42, 65, conversational, 120 is dangerous. Right? Are there any other values that I should probably test? Yeah, way above. So like what? 1,000. 1,000 decibels is blank. All right. That's not all that satisfying. At this point, what happens with 195 and above? What happens with negative values? We would need to go back and ask our stakeholders, what should happen with things that are out of bounds? Right? Well, they would probably tell you we don't want to support that. So let's have one last else statement here that says printf undefined. Right? Or some error message or something like that. Right? Remember that the else statement was always optional. There was our code before. But by placing it there, we'll capture anything greater than 190, greater than or equal to 195. Right? Undefined. What else should I test? I heard it before. Negative values. Negative 10. Can decibels be negative? No. Pressure can be negative. That's just pressure in the, negative pressure is going in the opposite direction. Flow, electric flow can be negative. That just means that it's going in the opposite direction. But it's still, the magnitude is the same. Right? Negative 10 decibels is conversational? Why? Well, is negative 10 between 0 and 60? False. So we move on. Because of our optimization, we have that negative 10 is less than or equal to 70, which is why we get conversational. Let's fix it so that we reject negative values. So let me have another if statement here. If decibels decibels is less than 0, then I will issue an error message. Printf error cannot have negative values. Right? And if you want to, we can quit on them immediately, or we can incorporate it into this else if statement. Right? And now I don't need to check the lower bound on this one anymore. Right? Either it's 0, or I wouldn't have gotten to this point in the program at all. Run it. -10. Okay. Hey, wonderful. Now that works. But I changed my code significantly at this point. I need to go back and test all of those other values. Did I break anything? 42 is still quiet. 65 is still conversational. 110 is loud. 120 is dangerous. And 1000 is undefined. You can see that testing, this kind of ad hoc testing, can get really, really complex because you make one change, you need to test everything again. Make another change, you need to test everything again to make sure you didn't break anything. Breaking is something would be called a regression, right? So these 5 things were passing before, except for this one right here. The 6th thing was not passing. I put in a bug fix so that that's now passing. I need to make sure and go back and none of those 5 things are broken again. Right? That's a lot of work if it's manually done. So what you do is you write code to do it for you. You write unit tests to test other code that tests other code to see if it's correct. And you'll be doing that in your, getting a preview of that in your lab tomorrow, where you have this is leap year function. You need to test whether or not a year is, like 2024 is a leap year. There's an extra day there. And so you write code to test that other code so that you don't have to do all this manually, manual stuff over and over and over again. Right? That's unit testing, though. Pretty good. Do we want to convert this to command line arguments? As another exercise really quick. Right? All right, so instead of prompting them for input, I got rid of that. Right? By the way, did I show you that trick before? How to get rid of an entire block of code really quick. All right, whatever you're selecting or wherever your cursor is, right? Command, I'm on a Mac, so it's command and then / back and forth to get rid of it. For Windows, it's probably going to be control and then / to do so. Right? Let's go ahead and get rid of that and then read it in as a command line argument. Decibels is, in fact, I'll just do it on this one line, is equal to argv sub what? So if I'm going to read this in as a command line argument, what's the first user-provided command line argument? 1. Is it going to work to just grab that command line argument? It's not an integer. How do I convert it over to an integer? A to I. There we go. I should probably be doing error checking here, though, right? If the number of arguments is not equal to 2, then I'll issue an error message. Error, enter decibels. Decibels, please. We'll be nice about it. And then I'll exit on them. Right, there we go. GCC. Enter the decibel, please. Okay, fine. 10 decibels there. Quiet. Right? 20. Oh, I guess I shouldn't have gotten rid of this, right? There. I'll restore that part. Okay. All right. Really easy conversion. I'll put this down here so that you have it in the notes. But any questions on that? No? You'll be doing something very similar but with tax calculations in your lab tomorrow. All right. Then what we'll do next time is we'll start on loops. Remember, you've got your reading due tonight, and if you're still working on Hack 2, we have help hours until 5 or 6 or so. Make sure that you're getting that done by midnight as well.